Now we want to find the area of this triangle that we have here. This is a simple 1/2 base times height. If you know your Pythagorean triples again. So since this base here is 10, it splits into 5 and 5. And now I can see that I have a right triangle here. That's a 5, 12, 13. That's a really common Pythagorean triple. So I'd 1/2. The base was 10. And now the height is 12. So if I do 1/2 of 120, I get my area to be 60, and that would be square feet. In our next problem, we did one similar to this on the assignment the other day. We have a diameter of 18 inches, and we're going to divide the pizza into 8 equal slices. So what I would do is just find the area of the entire pizza using pi r squared, and then divide that by 8. So my radius, if my diameter is 18, would be 9, and divide that by 8. So take 81 pi and divide that by 8. And you get 31.8 square inches. Now we're given a circle inscribed in a square. We know the circumference of the circle is 6 pi. So remember that your circumference is either pi times diameter or 2 pi r. I'm going to use pi times diameter. I mentioned that's the one I use the most. I know the circumference is 6 pi. So to get the diameter, I just divide by pi. So my diameter is 6, which tells me that my radius has to be 3. And the question is, what's the perimeter of the square? Well, if the diameter is 6, then that's also the side of this square. And I just need to do 6 times 4, which would be 24. And they don't give me units, so it's just 24 units. Now we're doing one of those where we take the big circle minus the little circle, because we're finding the area between them. The big circle is pi times the radius squared. And the big radius is 9. The little radius is 5. So that's 81 pi minus 25 pi, which is going to give me 56 pi. This is a more difficult problem. We have a square inside of a circle, and they tell me the diagonal from A to D is 8. Well, remember that a square, when you draw the diagonal, is a 45, 45, 90. So if that is 8, then this is 8 divided by the square root of 2, which is 4 square root of 2. So we now know that the side of the square is 4 square root of 2. And I want to find the shaded area. Well, the shaded area is a circle minus a square. So I want pi r squared minus length times width, or side squared. Oh, I wrote that formula wrong. So let's rewrite that. So it's pi r squared. But I know the radius of my circle, since the diagonal of the square was 8, then that's going to make the radius of the circle be 4. So we can put in 4 squared minus the length and width of my square is 4 square root of 2 for both of them. But then this is going to be 16 pi minus 4 square root of 2 times 4 square root of 2 is 16 square root of 4, which is 16 times 2, which is 32. In this problem, we're looking at a landscaping problem where we're trying to find the area between the rectangle and the circles, because we're wanting to buy some wood chips to fill in here, and the circular region is going to be my flower bed. So what we're going to do is we're going to take the rectangle minus, notice that we have a whole circle and 2 semicircles. So that's actually a total of 2 circles. Well, my rectangle is a 10 by 20 minus 2 pi times my radius squared, but the radius of my circle is going to be this length, which would be 5. So that's 200 minus, and 5 squared is 25 times 2 would be 50 pi. And now if I do 200 minus 50 pi, we end up with 429, or 42.9 square feet. But I can cover 5 square feet with 1 bag of wood chips. So now if I divide that by 5, I get 8.6, but we're assuming we can buy only whole bags of wood chips, so we would need to buy 9 bags. In problem 21, we've got a composite shape of a square, and we're trying to find this area between the square and the 4 quarter circles, but the 4 quarter circles actually add up to a circle. So if I take the square minus the circle, that should give me my shaded region. So my square we know is length times width, and my circle is pi r squared. So the length of the square is 6, and the width would also be 6, and then the radius of the circle would just be the 3. So that's going to give me 36 minus 9 pi, and they wanted us to leave the answer in terms of pi, so that's our final answer. In the next problem, we again have a composite shape of a semicircle on top of a rectangle, and we're wanting to put lights all the way around the outside edge. So now we're doing a perimeter problem. So we automatically know the other side here is 12, and the radius of my circle would be 5. So what we have here is a 12 plus 12 plus 10, that's all my straight sides, plus half of a circle circumference, because we're going around the outside edge. So I'm going to put pi d. So that's going to give me 34 plus 1/2 pi times my diameter, which my diameter is going to be 10, because that is the same as the diameter here. So then that's 34 plus 15.7. And if I add those together, I get 49.7, but it said to the nearest foot. So that would be 50 feet of lights. Again, another composite shape, but this time we're taking a square, and we're going to subtract out half a circle. So that would be length times width minus 1/2 pi r squared. They tell me that the side of the square is 6, so that's going to be 6 times 6. But if the side of the square is 6, then the radius of the circle would be 3. So that's going to be 36 minus 3 squared is 9, and half of 9 is 4.5 pi. In problem number 24, we have another multiple part problem. They tell me that from A to D is 12. They also tell me A to D and B to C are congruent, so this side is 12. And that this is a rectangle with side AB equal to 15, which means that the bottom is also 15. So the first question is, what's the perimeter of the rectangle? So we just need to add the 15, the 15, and 12, and the 12, and get a total perimeter of 54. We would have 30 plus 24. Let's try to make that 15 look a little better. Now, what's the area of the rectangle? Well, to do the area of the rectangle, I just need to multiply 12 times 15, and that's going to be 180. The radius of the circle is actually going to be only half of the side of your rectangle, so then my radius would be 6. Then the area of the circle is pi r squared. But that's going to be pi times 6 squared, which would be 36 pi. And then the last thing would be, what's the area of the shaded region, which we know to be the rectangle minus 2 semicircles, which would be a whole circle. But we know all those areas. The rectangle we figured out was 180, and the circle was 36 pi. So my area would be 180 minus 36 pi, and it does say the answers can be left in terms of pi. We're looking for the area of this trapezoid, and we know our formula is 1/2 h b1 plus b2. We know the two bases. They're 10 and 18, but we don't know our height. So we're going to divide this up into a rectangle and two congruent triangles. Well, this now makes the bottom be divided up into a 10, and then the other two sides together have to make 8 and be congruent, which makes them 4 apiece. So if I pull off this triangle, I know that my angle's 32 degrees. The base is 4, and I need the altitude because that also is going to be the altitude or the height of my trapezoid. So looking at my triangle, I need the opposite, and I know the adjacent. So that's a tangent problem. So the tan of 32 would equal x over 4. Put that over 1 and cross multiply. I get 4 times the tan of 32, but then that is 2.5. And now I can come back to my trapezoid formula and put in 2.5 for my height. And if I multiply 1/2 times 2.5 times 28, I'll get 35. And this was square meters.